Greetings! Check out what I scored today on a carboot sale. It's a box. It's really heavy. This is the front. It's got a nice handle and a clip. It's got a few rubber feet on the bottom, a couple of hinges. Nothing on this side, and on this side it's got old style British round pin plug, which is slightly damaged over here, but that's not a big deal. And can you guess what it is? So this will make it easier. The lid comes off and we've got some instructions in here, and we've got Clare Instrument Company safety test set for electrical appliances, model v.141. And here are the instructions that came with this. I guess you can read them if you wish. You can pause and read it. It's a Clare safety test for appliances and portable tools, model v2jkv. I've been told it's working. I guess it should be working, but just in case, I'm gonna overview this, have a look inside, make sure there's nothing terribly wrong with it, and then we'll do some tests, I guess. Looking at this from the outside, well, we've got this alligator clip with a banana plug on the other end, very old, very old. I'll probably replace the cable with something more fresh, and the banana plug is very worn out, but okay, it still fits in the sockets in here, so that's okay. The mains flex has been replaced. I'm quite sure this is not the original one. This is far too modern for this box. It's the soft flex. The plug is old, Dura plug, fused plug, but I'm quite sure that this is not the flex that it came with originally. And let me just turn this around this way. What we've got here is 4 lamps, a switch, two sockets, and a press to test button. And this one, it's got a really nice positive click to it. You cannot half click it by accident. It kind of jumps. It's a really old and crusty thing, but you know, it cost me £5 this, and I thought for what it is, it will be quite interesting to have a look inside and you know, restore it to its former beauty, and yeah, use it. I guess I can test my toaster or something. Anyways, there we go. And we can lift this panel out. Oh, come on. And what we see here is an absolutely enormous transformer. It's yeah, it's a massive transformer. But to see any more of what's happening in there, we need to take out the rest of the screws. So let's proceed with this. And we've got the rest of the screws out, so let's take the front panel off. Oh, there's quite a bit happening in there, but some cables are quite a bit short. How do I... There we go. This is being held with a very short section of wires, so it's not going to be an easy access. But worth noting that inside it's a really nice condition. I'm not sure whether this was serviced and cables replaced by someone, because well, they all look pretty well, I must say. They are all really, you know, good quality, and the rubber, the insulator is not deteriorating as it would possibly with an age of device like this. So okay, let me try to lift out the board a little bit. I can see that the socket, that's the old style socket on the front of on the side of the box, I think this was an afterthought, retrofitted later on by someone, because those wires that go to it do not correspond with anything else. They are not like any of the wires over there. So okay, I'll probably take it off and blank it out somehow, because I'm not gonna have a use for that plug, and it's damaged anyway, so it just gives me exposed 1000 volt output, which I'm not keen on touching. Anyways, it's worth noting, in a tester like this, you've got both live and neutral bridged out, as you can see over here. That's on both sockets, and that's because this doesn't test the continuity between live and neutral. And what a tester like this does, I think, now I'm deducing, I'm new to this, but it will put high voltage on. It will put high voltage on. Oh, screw is loose. High voltage on the live and neutral, and see if anything comes out on the ground lead. So whether it's safe. That's what I mean. It's a safety tester. So it will test whether the device is safe to use. And let me just double check the rest of the screws, because they are a little bit, it was a loose, that one, but no, the rest of them are fine. So what also what this will happen, I think it's this, those are relays. I think those are really big relays, and strangely there is also a winding, a secondary winding on one of the relays, and I'm not sure whether that's could this be for the high current? I'm not too sure. You've got massive wire wound resistors here, those will be really low resistance but really high power. You can see it looks like a spring. This must be like more than 1 millimeter thick wire, and that's all there is inside. And I must say, on the first look, it all looks in really good order. It looks like this was, well, looked after. There isn't anything visually wrong with it inside. It's a little bit dirty, that's on the outside, that's about it. So what I'm going to do now, actually I'm going to remove the wires going to the old style socket, just so it's a little bit safer to use. So I'm going to undo those two wires and take them out of the plug on the side. Now that I've got this socket isolated out, and yeah, this is somewhat safer, let's put this back in, screw the front back on, and we'll try to test something, see what happens. Yeah, let's plug it in and see if anything explodes. Okay, right, here goes nothing. Mains on. Okay, let's test it. It shows me earth fault. Okay, let's power it off. Now I thought what to test it with, and I think this is gonna be perfect. So this is my grounding plug for my ESD mat that I've made in another video, but this has got essentially both of those pins completely disconnected, and only the ground pin is connected to the mains earth. So if I do this like this and like this, this should be perfect, completely isolated from the ground, and a perfect path to the ground as well. So let's see, on and test. That's okay, perfect. Now Right, let's simulate some faults. Okay, here we have first test setup. What I've done is I've connected a tiny flimsy wire. I had to use separate set of crocodile clips because those are really, you know, worn out and they don't grab onto a thin wire. But basically, in this situation, the earth connection here is one flimsy wire. And what I suspect this is doing, it will put through 25 amps through this, so this should burn this cable out and return a fault. So let's see. Aha! It works! So yes, on this instance, the earth connection was rubbish and it burned it out and it showed fault. So it was a destructive test, but you wouldn't want to use an appliance like that anyways. So that's fantastic. What else can we do? Okay, and here I've done another test and I'm hoping the insulation fault will pop out. So basically I've put a 10 mega ohm resistor, which has just popped out for me. So I've not done a great job with putting that resistor in, but let's try again. Okay, that's better. So I've got a 10 mega ohm resistor between neutral and the earth. I've got 10 meg. Let's see what will happen. So let's see. Oh, it says earth fault. Oh, earth's not connected. Let's try now. Aha, it says okay. So apparently a 10 meg is too much. So 10 mega ohm appears to be a good isolation. So let's try something smaller. Okay, we've got 100 kilo ohm. Let's see. Well, that got toasted to begin with. Ha! Ooh. So yeah, it's trying to put out basically 1000 volts across a 100k resistor. If I put anything smaller than this, it will cause some damage. Well, it will keep burning them out. So let's try to just short out earth to neutral and see what happens. Ooh, it didn't like that. So I'm not too sure. So if there was a fault with a equipment where inside I could smell something crackling. If there was a fault inside an equipment where one of the wires became detached and touched the side, so it would touch onto the earth, what shouldn't this pick this up? I'm not too sure. Okay, let's try one more time, this time with a 1 meg resistor. So let's see what happens. Well, it's toasting my resistors, but it's saying that it's okay. So 100 kilo ohm got burned out instantly. How do I get the insulation fault to light up? Let's see how will VG here respond to 1000 volts on the volt range, I guess. So it shows 1200 volts AC. Okay. Yeah, 632 volts AC. So all that is working. But I'm still not sure how to get insulation fault to light up. All I get is okay. It seems like something's not entirely okay with this. I might have to investigate a little bit more, but probably not today. So for this one, that's gonna be it. A short little video of a vintage safety test appliance meter tester thing. So I hope you enjoyed it, and yeah, give me a like if you did, and subscribe for more random stuff, electricity related, I guess. And for the time being, take care.